we want to look at how does one evaluate the probability of events. So this is a question that you want to answer. How does one evaluate the probability of events? We want to look at a couple of examples to clarify an important concept now. So let's look at a couple of examples to clarify an important concept. So now the first example that we want to look at is that we have a random experiment where we roll 2 dice and we define this event to be A, that the sum of the faces on which the two dice lands is 7, and you want to find the probability of A. For this, what we can do is we can first plot the sample space here, where this represents the number on the first dice, 1, 2, 3, 4, 5, 6, and this represents the number on the second dice, 1, 2, 3, 4, 5, 6. And we are interested in all those outcomes that have a sum of 7. So this should be 1 plus 6 is 7. This would be 2 plus 5 is 7. This could be 3 plus 4 is 7. So it would be 4 plus 3 is 7, 5 plus 2 is 7, and 6 plus 1 is 7. So we can find probability of A here as number of favorable outcomes by total possible outcomes. Number of favorable outcomes are that the 6 outcomes which have a sum of 7. 1, 2, 3, 4, 5, 6. Out of the total, 36 outcomes. So this turns out to be 1 by 6. Now this is based on that since 6 out of 36 outcomes are in A. This is how we can find this probability of A by number of favorable by total possible outcomes. Now let's look at another example. Let's say the sample space is heart disease, no heart disease, right? So a person will either have a heart disease or have no heart disease. And let's say we define this event A as a person has heart disease. Does this mean that probability of A is 1 by 2? Right? But this does not reconcile with reality. Doesn't reconcile with reality. So now the question arises, so why did we evaluate the probability by computing the ratio of size of set A to size of S in 1? Over there, we did number of failed by total possible outcomes, but you cannot do same in example 2. In example 2, you can't compute the probability as the ratio size of set A to size of S. You cannot do same in example 2. So this is the question you want to answer. Now, this is because there was an assumption, although unsaid, in example 1, which was that outcomes in S were equally likely to occur. But same is not true with example, but same is not true with example 2. So the only so you can only find probability of number of favorable outcomes by total possible outcomes when your sample space is equally likely outcomes. So that's the key thing to remember from here. So only for sample spaces with equally likely outcomes, which happens when you have a fair coin, fair dice with equally likely outcomes. Probability of E is number of outcomes that satisfy E divided by total possible outcomes. That satisfy event E divided by total number of outcomes in sample space. So only in that case you can compute the probability as this. So this definition, the using number of favorable or total possible outcomes only work when the sample space is equally likely outcomes. This is very important. So you can only compute probability as number of favorable outcomes by number of total possible outcomes if your sample space has equally likely outcomes. Right? And this happens when you have fair coin, fair dice, and so on.